Okay, let's see. So let's talk about the functional groups here. Okay, can you name this guy? So what is the first thing that we want to do for our nomenclature?
Find the longest chain.
Find the longest chain. Okay, so let's see, we have 1, 2, 3, 4, 5, 6, 4, 5. So which one would be longest? 5, 6, 6, or 5?
6.
Okay, so what would this guy be called?
Heptane. Sorry, hexane.
Hexane.
Sorry.
It would be called hexane?
Oh, it's alcohol. Hexanol.
Hexanol. Okay. Anything else?
Yeah, it has 2. So it's 4, 5. Is it dimethyl?
So 4,5-dimethyl hexanol. Okay. Piece of cake?
Yes.
Okay, so we know that if it has this OH, and it can have any hydrocarbon, it's going to be an alcohol. It belongs to the alcohol family, or the alcohol functional group. So you'll see the term functional group. Or family. Okay. And if we remember in terms of priority, what was the priority? Who's at the bottom?
Are you talking about alcohol and
It
alkane?
was yeah, the alkenes on top.
Who's at the very bottom? Then?
So the bottom is alkane.
Okay. Alkane. Then?
And then
Who's
it's
above it?
Alkyne?
Alkyne.
The one with the Y. I'm not sure if I said it right.
Yeah, you said it right.
Yeah. Okay, good.
Then?
alkene.
And then?
Amine.
Well, you're ahead of them, so.
Was that class ahead of schedule for me?
Yeah, they are a little ahead of these guys.
Oh, okay.
Yeah, I had a meeting during one day that they had. And so we had a 30-minute lecture, so.
I remember that.
Okay, and then alcohol is actually above that. So I have to tell you about amines. Okay, so you guys remember alcohols, right? You're feeling comfortable with alcohols?
Yeah, so far.
I have one person answer. It's great. I'm glad we have a class of one, so we can go at the pace that we want to go to, right? So if I go too slow, just let me know, okay?
Okay.
Okay, thank you. Okay, so we have alcohols. Now, amines, have you heard the term ammonia? What is the chemical formula for ammonia? Ammonia. And you should know this because it was on the first exam like twice, and it's going to be on this exam probably like twice. And you guys realize that the practice exam is already up?
Yeah.
Yeah.
So I will be also emailing you guys, because I'm going to give it to you by email, because we get to check to see how many people check their email. I'm going to email you guys about 4 or 5 short answer questions, right? So that you guys also have some practice with short answer questions. So something along the lines, it's not going to be exact, but it'll be similar to what those short answer questions are, okay?
We have to turn those into the practice ones?
Nope, you don't have
Or
to
it's
turn
just
in
for us?
the short answer questions.
Okay.
Nope. You do them if you want to do them. If you don't want to do them, that's up to you. I'm not going to twist your arm. As my dad used
Yeah,
to
but
tell
it's
me.
like to do for ourselves.
Yeah, exactly. It's for you
Okay.
guys to do yourselves, yes. You can
Okay.
lead a horse to water, but you can't force him to drink. Okay, ammonia. What is ammonia? What is the chemical structure of ammonia?
It's NH3.
Ammonia is NH3. Now, amines are derived from ammonia. So it has an N. It has either an H or a hydrocarbon. It has either an H or a hydrocarbon. It has either an H or a hydrocarbon. So this is the generic form of it. I'm going to show you a couple of amines. Then we'll name them. Okay. So this amine here would be called just, how many carbons is this on this chain? Right here.
Is it 2?
2 carbons. And so what do we call 2 carbons?
F.
Okay, so we would call this guy ethyl amine. Okay. What about this guy? How many carbons do we have here? How many carbons do we have here? And how many carbons do we have here?
We have 6 carbons.
Okay, how many on each one? On each arm of the nitrogen?
There's 2 on each one.
Okay. So since there's 2 on each one, we call that, since it's 2 carbons on each one, we call that what again? You can tell it's a Monday. Are you guys tired?
Ethyl.
Well,
Ethyl.
Ethyl?
Yeah.
Well,
just
I guess we'll
okay.
use that same one. Ethyl.
Okay,
That's
so
very
then if I have 3 ethyls, what do I call it? What do I say then?
Triethyl.
Triethyl. Come on, triethyl amine. Okay, piece of cake? What
Kinda.
about this?
Yes.
What is this side group and this side group?
The left one has 2 and the right one has 3. So
So this one has 2 and this one has 3. So then we would call it, what do you think?
Ethylpropylamine.
Ethyl propyl
Propyl.
amine. Piece of cake? No problem? Not too hard?
Isn't this one the easiest one out of all the other ones?
Yeah, this is one of the easiest ones.
Yep.
Okay, so I'll give you one more for the road. And this one I'll help you out with a little bit if you want it, but if you don't want it, I won't help you.
What is that?
Well, we have 2 carbons, so there's an F in there somewhere. Maybe.
It's a F, what?
So there's an F in there somewhere because I see 2 carbons. But that's
Okay,
not
so there's an F in it. So it's F.
So is it F?
No H. Are these double bonds or single bonds?
Single.
Single.
Ethane?
Ethane. And then the alcohol.
Oh, ethanol?
Ethanol.
Ethanol.
Ethanolamine?
Ethanolamine.
What? That totally, we did not do that one last time.
Well, that's how you're answering all of them. You already did. You already had the sneak peek, huh?
Yeah.
I got to keep you on your toes, right? Not all lectures are created equal. They're the same, but they're not created all equal, right? Have to have a couple of.
So you think we should go to every lecture?
What was that?
So you're saying we should go to every lecture then?
Yeah, hey, it gives you a lot of practice.
Yeah, it does. This one's new. Let's see.
Piece of cake so far? Not too hard?
Yeah, don't erase it, not yet.
Not yet. I'll try
I need to
not
write
to.
this down.
Alan, talk to me, man. Talk to me. Let me know what's going on.
Good. Everything good.
Everything's good?
Yeah.
What about you, Hector? You got it?
Yeah, I so get it.
You so get it?
Yeah.
Jetsy,
I'm good.
you're good?
Mm-hmm.
I know Norma gets it. Norma lets me know when she don't. She's like, wait a minute, hold on. So I'm not worried about Norma. But Nadia,
Yeah, I
though.
understood it. Heard everyone.
Okay. Nadia, what about you? You got it?
Sorry, I joined a little late.
You joined a little late, but you're
Yeah.
going to catch up, right? You're going to be catching up with us here. You're hitting up your girl Cheyenne and say, hey girl, what did you guys just talk about? What was that functional group, right?
Yeah.
Yep. I need Cheyenne's phone number, Kristen. Who was the other one? Juan. I don't know. That got like the highest grades in the class for the exam. We need to study, guys.
Okay. So you guys ready for your next one? Now this one is the low on the totem pole, like bottom of the totem pole. And I'm going to show you the commonly used method because there is a new method that has been approved. I think it was approved about 2 years ago, but nobody really uses it. So I'm going to give you the most commonly used method. I'm going to give you 2 of those that are like that. Let's see. Oops. It lets me.
Is tomorrow's lecture going to be the same as today's?
No, it'll be a little bit ahead. Although I'm going to try to get you guys, I'm going to do a little hide the shell and get you guys a little bit of try to get you guys up to where they're at, maybe a little bit ahead of where they're at. It really depends on how you guys play with me. If you play rough with me, then, you know, maybe we can sit there and get ahead. But if you play soft and passive and all that crap, then we're not going to get there. It all just depends on you.
Well, I'm at work, so if you don't hear from me, it's because I'm busy, but I'll be listening.
Okay. Yes, I noticed that you're at work. Work for Toyota, huh?
Yeah, that's why I turned off my camera. But I can leave it on.
That's okay. You can leave it on. It doesn't bother me.
Yeah, we're
I
slow
like
right
seeing a
now.
working man. That means he has a
We're
job.
slow right now, so I figured I would pop in.
You know, I kind of start to wonder about my family sometimes because I don't get any phone calls on the weekends. And technically, the weekends are the day that I have to myself. They all want to call me during the middle of class, you know, and text me during the middle of class. I don't hear from them until midweek. Just don't know. Okay, so
Maybe
we
you
talked
should just
about
give them the Zoom link, and they can just pop in.
exactly. Yeah, that would happen though if I did give them the link, and we wouldn't get anything done because you think I'm a talker. Okay, so we'll talk about ethers. So ethers look like this. Ethers are real easy. I think we talked about ethers already, didn't we? You gotta help me.
Last week.
I think we touched on it. We didn't really go in depth on it.
We didn't go in depth on it. Okay. So we'll give you guys a couple of them and we'll see what you guys think. Ethers are kind of easy too, right? So, oops.
I have a quick question. Isn't ether with priority level in between alkane and alkyne?
Yeah, it's kind of weird, okay, because it's like I said, this is the most common way to do it.
Okay.
When it was done this way, the priority level was here, was above.
Yeah.
But now that it's done, there's another way of doing it by using oxy, right? Now that it's done that way, although everybody still uses ether at the end of it rather than call it an oxy whatever, they put it down here. So they changed the priority based upon it. So it would actually be, it would technically be right there above it. So anything that is above that gets priority over the ether, and then you use the oxy. So that's the way it used to be done. But now they're trying to unify the nomenclature a little bit better. So even though nobody still has adopted that process yet. So I'm teaching you the one that you will actually see on chemical bottles right now. Eventually it'll catch up, but it'll take it a while. And you guys will see this in OChem as well too. They'll start making that transition. They'll show you both ways and you'll be expected to know both ways. But right now, just for us, I just want you to know one way. Okay, so this guy, how many carbons do we have on this side?
Four.
So that's 1, 2, 3, 4. And then on the other side?
2.
2.
That's 1, 2, or 1, 2. Okay, so this guy would be called so what is a 5 carbon? I mean a 4 carbon?
It's Butte.
Butte. Okay. And 2 carbon. Okay. So it would be called butyl ethyl ether. Alphabetically, B comes before E, then ether. Piece of cake?
On the right side, why did you start it 1, 2, and then it like goes towards the
There was
O?
no reason. I was just being difficult.
Okay.
Just to keep your pant, okay. Just to try to keep you, keep you alert. Long weekend. Okay, so let's see. What about this guy? I know it looks like a spider, but it's not a spider. Let's see. Kevin.
Yeah.
Help me out. Give me a name. Preach, brother, preach.
Yeah, it's Monday. I'm kind of out of it right now.
Norma, you gonna help him out?
I'll try.
Would it be something like dipropyl ether? Because there's 2 of the same ones.
Dipropyl ether.
Yeah, that's what I was gonna say.
Kevin, if you need a study buddy, I can help you out with these.
Yeah, I'm gonna need help with that.
Okay, dipropyl ether. Piece of cake. Not too hard.
Not too hard.
Okay, good. Let's add a couple more functional groups. So we have the alkaline halides. Now these guys are pretty cool too, because what are halides? What are halogens? Those guys.
They are the ones with 7 valence electrons.
The ones with
gases?
7 valence electrons. So that's like who? Who belongs in that family?
I feel like chlorine's one of them.
Chlorine.
Yeah, chlorine,
Chlorine.
bromine, iodine, acetine. I don't know how to say that last one. Tennessine?
Yep, that's the family. That's the group. Okay, so now these guys are real easy because all you do is you're going to drop. So like, for instance, you have bromine, right? That's how you spell bromine. You just put bromo. So if we have, they look like this. X represents the halide, and then you're a hydrocarbon. Okay, so if I have 2, 3, and we'll do oops. My screwed up B. That's really a B. Okay, so we would call this guy what? How many carbons?
There's 2 carbons.
2.
2 carbons? Let me count.
3
I'm
because
old.
you
Are
doubted
there
us.
3?
There's 3
Oh,
carbons.
that's a branch.
There's 3 carbons. Okay, 3 carbons. So what do I call a 3 carbon?
Propyl.
Prop. Is it all single bonds, double bonds, triple bonds?
Single bonds.
Okay, all single bonds. There's no alcohols on them. And since this is the lowest man on the totem pole, we call it propane, but we call it 2-bromo propane. Piece of cake?
So are we basically just dropping the I and E and
That's
putting
right.
an O for all of them? So it'd be like
That's exactly it.
fluoropropane. Okay.
Yep. So let's see if we had this. Okay, what would we call that guy?
So it's a hexene. What was it?
Oh, sorry, you said hexene, right?
Hexene, yeah. I was
With
like,
an
am I mixing myself up here? Yeah, it was the E is double bonds, right?
E. Okay, I was just checking you to make sure that you guys are on top of it.
Yeah.
Come on, Brian, what else? Steve. Brian or Steve? Are you there?
It would be 2-bromo.
2-bromo.
And for the eyes, I'm not sure.
What do we call the eyes?
Iodo?
Ah, so how many are there?
There's 2 of them.
Di,
So it's 3 diiodo.
diiodo. And then what do we do about the double bond? How do we tell where that's located? So that's 1, 2, 3.
Oh, the double bond.
Where's the double bond located at?
At 1.
1. Okay.
I'm kind of confused. When did we go over iodines? I don't remember that from last Wednesday.
Well, we went over it just now.
It's just that like with the suffixes, I'm not clear on that, like how to change them according to the structure, you know?
Okay, so halides. What are halides?
Is it MO or is it just O?
No, halides. What family does, oh yeah, you just put the O, right?
Yeah.
So you drop the I in, like iodine. Look at this. So we have, tell me all the halides again.
I'm sorry, what?
Tell me all the halides.
Fluorine, chlorine, let me see here. Bromine, iodine, astatine. I don't know how to pronounce that.
Okay, so, whoops, I forgot iodine. Okay, so all of the ones that end with I and E, you drop the I and E, you put an O, and then you can account for the halides. These are the last ones on the totem pole, so whatever is above them has priority. it gets that last name. And then these guys are side chains, right? So this guy is a bromine. So we put bromo, 2-bromo. This
Wait,
guy is,
I'm sorry, I'm kind of confused. So, halides, or however you pronounce that, they're last on the totem pole, right?
yep,
So why do those go before the alkanes?
because they're last on the totem pole. So if you're at the bottom of the totem pole, you don't get the last name, right? So we're not going to call them, they don't end in a halide. This guy, alkanes are above them. So since alkanes are above them, then if it's an alkane, it's going to have the last name, right? Just like alkenes are above anes, right? So when we have this guy, what do we call this guy?
I'm sorry, I'm like really drained right now, so I can't really think. It's an L. There's a double bond in there.
Okay.
So would it be like one propene?
1, 2, 3, 4.
Oh, five, yeah. So that would be one pentene.
One pentene, right? Okay. E and E. Even though that there are single bonds here, it gets E and E because double bonds have priority over single bonds. Alkaline halides are at the bottom, right? They have less priority than anyone else. So alkanes, A and E, they are priority. They have priority over the alkane, the alkyl halides. So then these guys just count like side chains. So we just put for their side chain, it's bromo. This is a side chain. So it's attached, a bond between a carbon and a halide.
Okay.
Okay.
Yeah, I wasn't sure about that. So yeah, I didn't know that the ending name was like the most important one about that. I guess it was just kind of opposite to what I thought because it lists it in a certain way. So I'm glad that we cleared that up.
Okay. So that's why we call propanol, right? 3 alcohol, propanol, 3 carbon alcohol, 1, 2, 3. Alcohol has priority over all of these other guys. So it ends with the last name of the alcohol.
Oh, okay.
Okay.
Thank you.
And so, is that clear?
Yeah, for that little structure, would you mind writing out the nomenclature for that just so I can have it in my notes?
Which one?
The one that you just wrote at the top there.
This one here?
Mm-hmm. Yes.
So that would be 1. Okay. So let's try one more.
Am I supposed to do it? I'm not sure what we're doing here. Oh, I was just asking because I don't know how to do it, so I still need more practice.
Anybody want to help her out? First thing that we do is do what?
Find the longest chain.
Find the longest chain. So what would be the longest chain?
Hmm.
5.
1, 2, 3, 4, 5. Okay. 5 chain carbon. Cheyenne, 5 chain carbon.
So it would be pent.
And okay. So all single bonds.
Yeah. So pent and
Pentane.
pentane. Yeah.
Okay. So what do I do with those halides?
So you'd start with chlorine since it's alphabetical,
Okay.
and it would be 2-chloro, I think is how you say it.
Yep. And then
2-fluoro.
and then
3-iodo, I think is how you say it.
fish cake.
Are the halides always going to be like a branch, at least for this section?
Yeah.
Okay.
They're always going to be a branch. They can
Okay.
also be at the end. You could have a terminal one, but still, in that case, it would be one. You know, you could have one at the end, technically.
Yeah, but it would be like one bromo and then you're.
Yeah.
Okay, cool.
Okay, questions, concerns, cash, credit, cookies. Okay, so that is, we're doing pretty good there. Let's add a couple of more friends.
Are we gonna have to memorize all the prefixes for the quiz, or?
Yep.
Oh, all
You
right.
need to be able to identify the functional groups.
Yeah, but like we can't have like the S's and propes written down on the side or anything. We gotta memorize all of the prefixes.
Yep.
Okay.
If I can remember them, you can remember them. I'm old. I forget half your names by the end of the day, plus mine. Okay,
Cool.
let's see. What do we have? What do we have? Okay, these can kind of do together. So we have ketones. We have aldehydes. And we have carboxylic acids. Okay, so I'm going to give you the generic structure of each of those. Then we'll test your naming abilities.
Wait, so which ones are these?
I'll give you the name in a second. Okay,
Oh,
give me
okay.
1 second. Let me finish drawing. And
It's
then
okay.
oops. So these are ketones. These are aldehydes. And these are carboxylic acids. The ending you're going to use, oops. So the endings that you're going to use for this guy is going to be O-N-E. For this guy, it's going to be Al. And for this guy, it's going to be oic acid. Okay. So again, you always want to find the longest chain. So 1, 2, 3, 4, 5, 6, 7, 8. And then we'll do so this guy, longest chain. So this also counts as a carbon. So this really here, it looks like this. It's C double bonded to an O. And then it's attached to another hydrocarbon attached to more hydrocarbons. So all you want to do is find the longest chain. So let's count. How many do we have here?
10.
1, 2, 3, 4, 5, 6, 7. Oops, forgot that one. 7. That's 8, 9, 10, 11. Okay.
I have a question. Which one is 2 on? I don't know if it makes any sense, but
One, 2. 2 is that carbon right there. That's double bonded to the O.
oh, okay.
Okay.
Thank you.
So then the name of this guy would be, we have to get the location of that double bond, from the carbon double bonded to the O. So it's 2. And then you would call it undecane, or not decane. own. Undecane. Oops, I got carried away with my anes. There we go. Undecanone. Okay, so the AN represents all single bonds here, and the ONE represents the functional group. Simple?
Yes.
Okay, so let's see. Okay, what about this guy?
I'm gonna try to do it just because. So, can you? Well, it's just a bit hard to see there.
Are you saying it's hard to see the location, or it's hard to see what I drew?
Do you know how, like, the previous one, it was like clear that there's a separation there up to the O? Is that what it's supposed
Yeah, it's
to
still
look
a
like?
double bond. Yeah, so that's still a double bond.
Okay.
Let's see. So it's still right here, double bonded.
Okay. So there's 1, 2, 3, 4, 5, 6 carbons, correct?
One. Am I counting the right way?
Well, I don't know if you are.
Okay. So which one is going to give me the shortest distance to the structure? If I count it from the left or to the right?
From the right.
Okay. Okay, so we're at the shortest distance. Okay, so then.
Okay, so yeah, it's 6, so it would be 2. Oh no, sorry. It's 3. It's 3, right?
Yep.
Hexane unknown. Okay.
Excellent. Okay. Piece of cake.
For me, I don't know about anyone else.
One more for the road. How about that one? Jennifer.
Hi. Okay. It's would you be able to move it over? Oh wait, never mind. I see it now. Oh, there we go.
Okay.
Yeah. I had like a bar in the middle of it. Okay, so we have 1, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4. So it's 4 dash. Or do you want me to write it? Okay.
4 dash.
Oct. Unknown. And then in front of that would be 2 dimethyl. Sorry, not ethyl, methyl.
2,2-dimethyl 4 octanone.
Yes.
Piece of cake?
Yes.
Hector, you got it?
Yeah, so.
So.
Hmm.
Okay, so let's see. Okay, so now this guy works the same way. You want to find the longest carbon chain. And the only thing is that aldehydes are terminal, meaning that they're always at an end. So what would be the longest carbon chain for this first one? Where do I start?
There's 8, isn't there? And you start at the where the double bond with the oxygen is.
Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it'll be, are they all single bonds?
Yes. From what I can tell.
So what do I use for single bonds?
Ain.
And then since it's an aldehyde, since it's an H attached to an H, we're going to put Al. Actinal. Okay, piece of cake?
Yes.
Hey, Hector. Help me out with this guy. Are you there, Hector?
Yes.
Okay. So help me out with it. Longest carbon chain.
You would start from the double bond.
Okay. So that's 1, 2, 3, 4, 5. So we got a 5.
Pent. Pentene.
Is it single bonds,
Pentene.
double bonds?
Oh, it's single.
So pentane. And then what are we going to put at the end?
Al.
Okay. And what about the side chains? 2 side chains. This guy here and that guy there.
Three. 4.
Since there's 2 of them, we call it.
Di.
And how long are those chains?
What do you mean by how long?
Okay, like how many carbons do they have on it?
Oh, just one.
Just one. So that would be, it's one. Is it meth, eth, prop, but?
Meth.
Okay, so 3,4-dimethyl pentane, pentanone. Piece of cake?
Yes.
Yeah, getting better.
Okay, so our next one is carboxylic acids. So for carboxylic acids, we have okay. So longest carbon chain. Let's see. Nadia,
Yes.
longest carbon chain. Where do I start counting at?
Would it be the one in the center?
You're talking about this one that's attached to the double bond?
Yeah.
Or this one right here?
The one that's attached?
To the double bond, okay, so that's one. Different color. So that's 1, 2, 3, 4, and 5. So a 5 carbon chain, single bond,
Say pent.
and single bond.
For single bond, is it AL?
Not AL. AL is for aldehydes.
Oh.
Look over here. What ends with, you're right, it's an A,
AN?
AN, and then we put O, dick, and acid. Okay, pentoic acid. Simple?
Yeah. Okay.
Okay.
I get it.
Let's see, Brian,
Yeah.
this one's for you. Hey, Brian, that's your crazy structure.
Alright. Is there BR at the end?
What was that?
Is there BR at the end?
That's a BR at the end right there. Let me fix that. Is that a better B?
Yeah. Let's see. So there's 7 carbons.
Okay.
So we have
Okay, 7 carbons are called.
Heptane.
And since you have double bond OH here, what are we going to add? I think we lost him. Are you there, Brian? So what is going to be the ending?
Heptanoic acid.
Okay.
So the reference can be clean off.
Okay. So what's going to go in front?
7-methyl.
I mean 6 carbon. 6 methyl. And where's that Br located at?
6.
Okay. It's also at the 6. So 6. What do I use for Br? Come on, bro. You got this. Brian, come on. You got this. Brian-O.
I'm not too sure.
What was that?
I'm not too sure.
You're not too sure? You're not sure, Brian-O? Anybody want to help him out?
Bromo.
Alan. Bromo. Yeah. 6 bromo, 6 methyl, heptanoic acid. You got it? Piece of cake?
Yeah.
Okay. How you feeling about all the functional groups? Good, bad, or ugly?
Good.
Okay.
Yeah,
Okay.
I definitely need more practice, but I'm pretty good.
Pretty good. Okay. So the key things you want to be able to do is to be able to identify them. So identify which functional groups they are. And be able to name them. Most of the names are going to be, I'm going to try to keep them relatively simple. They may have side chains, but it won't be like crazy side chains. Unless it's extra credit.
Extra
Okay.
credit? Heck yeah. Take it.
Okay, so let's move on. You ready to move on? So those are the things that I want you to know for organic chemistry. It's mainly nomenclature and being able to identify the number of bonds, double bonds, triple bonds. There's one last thing before we move on. I want you to think about it. So what are proteins made up of?
Amino acids.
Amino acids. Excellent. So this is the generic structure for an amino acid. Okay, so what is this functional group called?
Amines.
amines. And this functional group?
Carbolic acids.
Put them together, you get amino acids.
Oh,
I didn't know that. That's cool.
yeah, me either.
Okay. Are you guys ready for some more knowledge?
Yeah, don't erase that yet. Hold on. Is that
Okay.
H2N for the
That's-
amine?
That's NH, yeah, it's H2N, yes.
Okay, you're good. Thank you.
Okay. So are you guys comfortable with these functional groups? Now, there are a lot more, but these are the only ones that I want you guys to be aware of right now, okay? And I did show you guys cyclos, right?
I don't think so.
I don't think so. What would this guy be called? I know it's a horrible drawing. How many carbons?
6.
6. So this guy would be called cyclo. And 6 carbon. What is the name of a 6 carbon single bonded?
Hexane.
Cyclohexane. Okay, so if it connects, then it's a cycloalkane. Okay, that's all I got for organic chemistry. And then now I'm going to start with inorganic chemistry. Inorganic chemistry is easier than organic chemistry. At least in my belief it is. Okay. And you guys have started it already, sorta. So let's say we have sodium. Sodium is going to form what type of ion? What's going to be the charge?
Na plus, positive.
Na plus. Sulfur is going to form what type of ion? What's
Negative.
going to be the charge? Negative. Just one negative?
Hold on, I need to look at the periodic table.
Okay.
-2.
-2. Okay, so if I have 2 negative and I have 1 positive, are they going to equal 0?
No.
No. How many of each will I need to make it equal to 0?
1 sulfur, 2 sodium.
I'll need 1 sulfur and 2 sodium. So ionic compounds always will equal 0. So when these guys come together, they won't have a charge associated with them. And the way that we would write it is, we'd write the 2 as a subscript to let me know that it's in a compound with the sodium and they're balancing each other out. Okay? And so we would call this guy sodium sulfide.
How do you know which suffix to put on it?
Well, the metal doesn't get a suffix. You notice sodium.
Mhm.
Sulfide, you put IDE, that represents two things. One of the things that it will represent, it has two possibilities. It represents the possibility that you're at the end of the name, right? Or it represents a negative charge,
Oh,
okay? So if we have lithium and nitrogen, what is going to be the charge that the lithium has when it forms an ion?
lithium plus.
Okay. Okay, Alan, what is going to be the charge on the nitrogen?
Negative.
How many negatives? Just one negative? Two negatives? 17 negatives?
It would be 3?
That's right. It'll be 3 negatives. Okay, so if I want to balance these guys out, how many lithium am I going to need? How many nitrogen am I going to need?
Three lithium.
3 lithium. And then how many nitrogen?
1.
Okay, so then these guys will come together, Li3, N. And this guy would be called, what do you guys think it's going to be called?
I would guess probably like lithium nitrate or something.
Lithium nitride.
Oh,
Okay, let's see. Let's see if we have. Okay, so if I have aluminum and I have oxide, what is going to be the charge on aluminum? Alexandria. Are you there, Alexandria? Okay, Kevin.
I think it would be +3.
Okay. Okay, what about the oxygen? Cheyenne.
It has a 2 minus.
Okay, for these guys to balance each other out, how many aluminum will I need and how many oxygen will I need? Steve.
I'm gonna say 2 aluminum and 3 oxygen.
Okay, that is good. That equals -6 and +6, so it's perfect. So we have Al2O3. Is that correct? And what would that guy be called?
is it aluminum oxide?
That is correct.
So would there be any time where it would not have the IDE suffix?
It's going to always have the IDE suffix if it's interacting with a metal. So you have a metal and a non-metal. These are just ionic compounds. You're always going to have, your metal's going to have a no suffix, and then your non-metal will have an IDE associated with it. Okay, let's see.
Thank you.
Let's do this one. This is the one that, okay, if I have magnesium and carbon. Kristen.
Okay. Sorry, I was busy writing down the rest of that stuff. But it's for magnesium, it's positive too.
Okay. Norma. Carbon.
I'm not too sure.
You're not too sure? Nadia, you want to help her out?
I'm not sure either, but would it be 4?
Is it a positive or a negative?
Negative?
That is correct. Okay, Jason, how many am I going to need of each?
You're gonna need 4 magnesium and 2 carbon.
I'm going to need 4 magnesium and 2 carbon. Are you sure?
Yes, I don't know how to do math. Oh, I could just do 2 magnesium.
2 magnesium.
1 carbon.
That's right. 2 magnesium and 1 carbon. Okay, so then my chemical formula would be, Brian?
Magnesium chloride or carbide.
So Mg, so magnesium carbide.
2 or Mg2C.
Okay. Okay, so Mg2.
Yeah.
Okay. Piece of cake?
Yes.
Yeah.
Okay. So if we were doing, I know I only have 3 minutes left. So transitional metals are kind of weird, right? They're in transition, they change. So they're not always going to have the same charge associated with them. Sometimes they'll have a 1 charge, sometimes they'll have a 2 charge, sometimes they'll have a 3 charge. The way that we determine what charge they have, we have to give them a Roman numeral. Let me give you an example. Or we have to, it depends on who they're working with. So if we give you iron 3 chloride. So this tells us that our iron has a +3 charge. And we know the charge of chlorides. What is the charge of chlorides, Kevin?
-1.
Chloride is a -1. So how many chlorides will I need to balance this guy out?
3.
So then we write the chemical formula as FeCl3. So if I have this chemical formula, Can you tell me the name of this compound?
Anyone?
Anyone?
Would it be iron 2 oxygen? Oxide? Oxide.
Are you sure?
Mm,
So what is the charge on the oxygen?
let's see.
So would the oxygen go before the iron then? Or no, would it go after the oxide?
Nope.
Oxygen is O2 minus.
Oxygen
Right.
is O2 minus. Okay.
Oh, so would it just be iron oxide?
Nope.
No.
Nope.
Damn it. I'm just spitting out whatever. Okay.
Iron 4 oxide.
It would be iron 4 oxide. So
Walk us through it, please.
yes, we will walk you through it. Do you want to go ahead, Kevin? Do you want to walk them through it, or do you want me to walk them through it?
Yeah, I can do it.
Okay.
So since we have the FeO2, that means we have 2 oxygens, and each oxygen has a -2 charge. So you're trying to balance out
Oh,
a
okay.
-4 charge. And then as we saw in the previous example, since we had a iron 3, so that means we had 3 plus. So right here, it would just be 4 because it would give you a +4 charge to cancel out the -4 charge.
That's a question mark.
Wait, hold on. This one. Oh, I see. Okay.
Okay.
Yes.
Okay. Let's see. Let's do. Okay. So what would we call this guy? Nadia, do you want to help me out with it?
I'll try.
Okay. So help me out. What is the charge on that sulfur?
3.
Okay. The charge on the sulfur is a 3. We have 3 of them. What would be the charge on each of the sulfur? Look on your periodic table. How far are they from being a noble gas?
Two.
It's 2. So it'd be a -2 charge. Okay. So if we have 2 gold, what has to be the charge on this of each of the golds for it to balance out this negative total? 3 times -2. 3 times -2 is what?
-6.
-6. Okay, so each goal has to be what to balance out that -6 charge? So what is the charge of the gold if it balances out that -6 charge? So if I have 2, we'll use y. 2y minus 6 equals 0. So what does y have to be?
Can anyone answer, or you're just waiting for her to answer?
Anyone can answer. Do you want help? Well, I'll ask her. Do you want help?
Yeah, please.
It would be 3. Y would equal 3 because you have to cancel out the -6 charge, and you have 2 golds. So both golds are +3. And they add up to 6 positive, and they cancel out the 6 negative.
Okay, so our name would be Cheyenne. You gonna help me with the name?
Did you say Jen?
I said Cheyenne.
Oh, Cheyenne. Okay. I'm like,
Would it be gold and then like 3 for the Roman numeral and then sulfide?
That is correct. Piece of cake?
Yeah.
yes.
Okay, so now you've learned transitional metals. You learned group 1 and group 2 metals. You notice group 1 and group 2 group 1 and group 2 metals, we don't put Roman numerals on. Did you guys notice that? Okay, good. So there are a few transitional metals that if you don't see Roman numerals on them, you make assumptions, okay? Those are zinc. If you just see zinc chloride, right? So that means that zinc is a 2+. So zinc. So if you see zinc chloride or zinc oxide, you know that it's a 2+ for zinc. And that's if there's no Roman numeral. Oops. Okay. Silver is going to be 1+. If you see silver, silver bromide,
Are we basically just assuming that there's one of the other element, basically? Like there was one chlorine and one bromine to figure out a charge?
no. In this case, you'd have 2 chlorine, but it's just kind of understood. There's ones that,
okay.
because zinc, the most abundant form of zinc is zinc 2, right? Zinc 2 ion, the most abundant form of the ion zinc.
Okay.
And there's one more, but I can't think of it right now. But occasionally you'll run across these guys and they won't have a Roman numeral on them. Now, there'll be other cases where they will have Roman numerals on it, and then that overrides what it is, because there is zinc 3 and there's zinc 4. So, but they're less abundant. Okay? Questions, concerns, Cash? Okay, so this is a good stopping point. We'll go over the rest of it on Wednesday. And then you'll be ready for your test. Okay? Good,
Okay.
good.
Real quick on the test.
Yep.
I know we went over molecular geometries, but I noticed on the homework 6, there was one group called octahedrals. And
You
there's
won't
like
have to worry about
T-shaped
those.
and seesaws. We don't have to worry about those.
Yeah, you don't have to worry about
Okay.
those. You guys
Just
only have
kind
to
of what
worry
we went over.
about quads. That was my bad. I didn't clean that up. So next
Okay.
time I'll have to make sure to clean that up for the next group. So
All right, just making sure.
yeah. Any other questions? Anybody want to give me $2 million?